just in case you weren't here or that you need like an extra incentive or something to do well on this. We are taking our constructed response final exam this Thursday. It was supposed to be tomorrow, but I decided to move it to Thursday because basically one of my classes is behind. Plus, I do think that this works out. Table 2, stop. I do think that this works out because the constructed response final kids tend to do better on, and there's extra credit attached to it. So yeah, I really want you to take this seriously, pretend like it's the real thing and have everything answered like you normally would a constructed response. So the way that I grade it as far as the extra credit goes is, so there was 3 units or 3 main units. We also did unit 3, so we'll talk about that in a second. But for each unit, it's like 10 points. It's out of 10 points. But I encourage you to try both. So say you get both parts of unit 5 right, you could get a 20 out of 10 for that section. Say you get half of this question right and half of this question right, you still get a 10 out of 10. Right, so just whatever you get for that section, I score it out of 10. So that's what I'm telling you. Do all of it. Even if you are throwing out a guess, you might be right. Or I can give you something for attempting, who knows? But that's how I grade it. So really, if you do the whole thing and you get all of it right, you could get a 60 out of 30. But then also this class, I taught you unit 3. So I'm gonna make that also an option. So it's optional, just like doing the whole thing here is optional. You have to at least do 1 from each on your real test. That'll make unit 3 optional and extra credit. So say you get both the questions from unit 3 completely right, then really you could get an 80 out of 30. That's a lot of points. And it's going in 1 category. So that will bleed into the other categories, like it'll make up more. Like it won't just be 10% of your grade. It will be like, if you score over 100%, it will be like, I don't know, 20%, 15 to 20%, something like that. So a lot of incentive there. I've had kids that like last semester had a low, not a low F, because that wouldn't work, but a high F, and they went all the way up to a C. So it's still possible. In addition to like coming to tutoring, making sure your grade is like as high as it can be, it's still possible, and this is a great opportunity for that. Because previously in the past, before we started doing constructed response portions, it was just that multiple choice portion that you take on final exam day. And from my 3 years teaching the class, students usually don't do that well on that part. Why? I don't know. I mean, I still give you a review that's aligned to it, but kids just don't. They just don't do well. So that's why previously I've always told my students, just assume that it's going to bring your grade down. Make your grade as high as it can be before you take your final. But now with this, assuming you take it seriously and you do all of it like I'm telling you, I think this is a great opportunity that it could raise your grade and all of that stuff. So any questions on how it's set up? What'd you say, Drew? This is part of your final exam. So this is the part of your final that you're taking Thursday. The other part you take on final exam day.
Right. Yes.
Those in the 10% category, yes. And then what else? What else? It's this many. It is exactly like this, but just different numbers. As you can see, like here it says car, but here it says phone. That's because whoever edited this forgot to edit that part. We literally just make a copy of the text and change it, and then give it to you as a review. Like the one you take on final exam day? Yeah. I want to say 18 and 20. So there's that. You do also have the option, it says on here in case you forget, but you do have the option to make a 3x5 note card as like your cheat sheet. The only thing is you can't take that note card with you then when you leave. You have to leave it here. So consider that. I had a teacher once show us how to, on Microsoft Word, measure out 3 by 5 inches and make the font like really small so that we just have to print it and then tape it to our note card. So like, that's a great little incentive that they're giving you You could really copy your whole study guide onto that note card. So the study guide looks exactly like the real thing. So any questions on that? All right, tomorrow I'll give you the review for the unit 3 portion. Because we're gonna go over some today, probably go over some tomorrow, but yeah, there's that too. So which ones do we still have questions on after reviewing it? So unit 6, the second one. Okay, so everyone look at unit 6, the second one. Let me erase. But it says use a diagram. I don't think you really have to, not everyone thinks that way, but they were trying to get you to think back to something that we did in that unit. So remind me, what was unit 6 about? What do you mean by shape? Okay, can someone else tell me what unit 6 was about? Sorry, I just kind of want to cover this so that you guys are distracted. But what else was unit 6 was about? Solving quadratic solve. So was unit 7 too. There's probably different ways. But in unit 6, we had to determine if stuff was equivalent or not. So like for this one, it says show, so kind of ignore the use a diagram part. You don't really have to. But show that 5x plus 2 in parentheses times x plus 3 in parentheses is equivalent to this. So that a factored form is equivalent to a standard form. It's not saying, tell me if it's equivalent or not. It's telling you to show. So this is already equivalent. You just have to prove it. What's a way that you could prove it? Foiling. You could foil this. You could also factor the standard form and see if it gives you the other part. But I do think that foiling is probably the easiest. So 5x plus 2 in parentheses, x plus 3. FOIL stands for what? First. So multiply the first term in each parentheses. What's 5x times x? 5x squared. Outer. What's 5x times 3? 15x. Inner terms, what's 2 times x? And my last terms, what is 2 times 3?
6.
Okay, so that's foiling. Doesn't quite look like what we're supposed to have it look like. What do we normally have to do after that part? Combine like terms, which are what?
15, 5x. 15 and 2x.
And then when you add them, you get
17x.
and then the others are still there, they just don't have any like terms. And then because foiling it, you get the standard form, that proves it, they must be equivalent. So questions on that? Okay, so then let's look at the second part. The second part is asking, is this equivalent? So in that part, you would say either yes or no, depending on what it is. And yeah, so we have to figure that out first. What's the way that we could figure that out? We could FOIL this part. Now, what do I have to do before I FOIL? Because I don't see a first, outer, inner, last. You want me to put squared on each of them?
No.
Oh, okay. So, yeah. I think what this question is trying to see that if you will do this is make a really common mistake that students make. A lot of students will try to just distribute that exponent. And then they'll say that it's x squared plus 9. And then they'll say like, no, it's not equivalent. So don't do that. What do exponents tell us to do? Multiply what? It does tell us to multiply, but multiply what?
Itself.
Multiply the base by itself, however many times that this says. Is it about this? No, no, no. So that's why it's x minus 3 times x minus 3. And then now you can FOIL. So first terms, what's x times x?
X squared.
And I can already tell it's not gonna be equivalent, because that's not 2x squared, right? But keep going. What's x times negative 3?
3x.
Inner terms, negative 3 times x.
3x.
And the last term, negative 3 times negative 3. Positive 9.
I said no.
And then combine like terms, and what are our like terms?
3x.
And when I combine them, I get,
-6.
and then bring down the other stuff that doesn't have like terms. And then are these equivalent?
Oh, no.
So the question is asking if these two are equivalent. And it also says explain or show your reasoning, so don't forget that part, don't just tell me no. Say no because
They go back.
the equivalent expression for x minus 3 in parentheses squared is x squared minus 6x plus 9. So like showing your work or having a sentence like this, or both preferably, is how you would get those full points for that one. So questions on that? And it won't necessarily be no on your final exam. I haven't even made a key for it yet. So just know, like, you have to see, are they equivalent, and then explain why or why not. What other ones do we have questions on? All right, table 3, set up. What other ones do we have questions on? Or do we already know everything? Are we ready to take the test tomorrow, maybe? Jalen? Unit 5, the first one. Can you guys remind me what unit 5 was about? I know that was like the first one this semester. What? No. I tried. Function notation is like in every single unit, so not necessarily.
It's dreaming. Like,
A certain type of function, so not quadratic, exponential. It was about exponential function. So that alone kind of helps me, because what formula do exponential functions have? No. Okay, maybe we'll come back to that. All right, but that would be something to put on your note card, like the most basic formula for exponential functions. So it was the first one that we had a question, right? Okay, so a car that was originally sold for $18,000 loses 1/5 of its value each year after it was bought. After 4 years, how much is the car worth? And then also it says write an equation for the value of the car T years after it is released. So I kind of wish that they swapped the questions, because I feel like you need an equation before you can answer number 1. So to make an equation for it, I'm gonna kind of have you look at number 2 for a second. So in number 2, this one, here's an example of something that's an exponential function. So in this example, what is that 1,000 referring to? The starting amount. So that, remember, was part of our exponential function formula. We called it A. So what's my starting amount for number 1? Well, for this problem. So then for my equation, and it wants us to use function notation, so E of t equals A, my 18,000 is my initial amount. And it's gonna be times something, because normally it's times by B, which is our common ratio. Do you know what you would times by each time to get the next value?
0.2.
Okay, so Ryan says 0.2. So let's kind of think about that. If it's losing a fifth of its value each year, then what is it going to be after 1 year? So after first year, it lost a fifth of its value. So what is its value after 1 year? Let me grab a calculator, consider doing the calculations yourself too. But if I times it by 0.2, it's saying that it's already worth 3,600. So is that what, does that sound logical? Because it's only losing a fifth of its value. So we're not gonna times it by 1/5. Do you guys remember what we times it by? We're gonna times it by 4/5, which is what it's keeping of its value. Right, because 1/5 of its value is 3,600, right? So after 1 year. Hold on a second. So after 1 year, it's 14,400. Right, so you would multiply it by that and then subtract it from that to figure out what it is after 1 year. Or you could just multiply it by what remains. So 18,000 times 4/5 is that same number. So it was another way to get the same thing, but exponential functions has it multiplying. Do you guys remember that now? Maybe. So you're multiplying it by what it's keeping of its value versus what it's losing. And then, do you guys remember how to put like the time into this exponential function? Exponent of t. Or sometimes they do x, but this one wants us to use t. So this is our equation, that answers that. So if you want to put that on your note card, I would put initial amount. Well, I would also put this over here, but I would put initial amount. We're multiplying what remains of its value versus what it's losing. Because that's what we're multiplying by each time. And then of course time. So then after 4 years, what would I do with that 4? You plug it into your equation. So then 18,000 times 4/5 to the 4th power. And you do need a calculator. I don't think there's a way you could really do that without one. And you can just type it in all at once, so you don't have to worry about order of operations. That could be tricky. So 18,000 times 4/5 to the 4th power. And that's what it's worth after 4 years. Make it look like money. How many decimal spots does money have? 2. So my answer for this is $7,372.80. Questions on that one? All right, questions on any others? All right, going once. Going twice. Remember, you're taking this Thursday where it really counts and there's extra credit involved and all of that stuff. Okay.